Hi guys, so today we will solve today's Leetcode challenge, and the problem is Leetcode 3761, minimum absolute distance between mirror pairs. It's a medium problem, and let's read out the problem what it says. So you're given an integer array nums. A mirror pair is a pair of indices I and j such that i's and j are in between 0 and nums dot length. So and reverse of nums of I and j is equal to nums of j, where reverse of x denotes the integer formed by reversing the digits of x. Leading zeros are omitted after reversing. For example, reverse of 120 would be 21, not like 0 to 1. Okay, so return the minimum absolute distance between the indices of any mirror pair. The absolute distance between indices I and j is absolute of I minus j. If no mirror pair exists, then return minus 1. Okay. So this is our nums array that is provided, and we have to find the minimum absolute distance between mirror pairs. And there can be multiple mirror pairs. So if we just see this example, so here there is 12. So mirror of 12 is 21. So this is 21, and we have this indices difference if I say. So it is like index 0, 1, 2, 3, and 4. So here the difference is 1. Okay, so from here we calculated this difference is 1. Then we see 45 in its reverse is 54, that is also there. So difference between their indices is 2. But among these two mirror pairs, there were two mirror pairs, this is the this one is the minimum absolute difference between the mirror pair. So 1 is the answer for this array. So we'll start solving this problem, and if we look at the problem, what it basically says that while going over the array, we want to know if the reverse exists in the array or not. So what we can do is, let's say this is our array, and while going through, so what I'll do, I'll see, okay, if 12 is there in the map or not. Okay, so I mean for 12 the reverse is 21. 21 is there in the map or not. Currently there is nothing, map is empty. So I don't have the reverse. Now I come here 21. For 21 I see what is the reverse. I see the reverse is 12. After 12 okay, sorry, for 12 we would have added its index also. Okay, 0. Now I came to 21. For 21 I see what is the reverse. It is 12. It exists in map or not. It exists at index 1, and my current index is uh, it exists at index 0 and my current index is 1. So the difference is 1. So minimum distance variable which we can keep, and it can be some int max value, let's say. So I see that it is currently the difference is 1, so I can definitely have the minimum value as 1, and then I will put 21 into my map. Okay, so my 21 is at index 1. Now I came at 45. I see for 54 exists in map or not, which is the reverse value. It not. So I'll just put it into the array. Okay, now I come here and I see 33. 33 doesn't exist in map. I'll just add it. I came here, and for 54 reverse is 45. It exists in map or not? So it exists in map. So for this we will see the difference in their indexes. So currently the index is 4 and their reverse index is 2. Difference is 2. Difference between these two are 2. And I'll see if it is minimum than our stored minimum. It's not, so we won't store. After going over all this, we get to know, okay, this is the minimum. Okay. Now there is one key thing over here. We calculated this way, but if we see, right, uh, for example, let's say instead of 33, I mean, after this, we would have also added 54, which is at index 4. Now, let's say the array would have something like array would have been something like 12, 21, 45, and again 45 and then 54, right? Now if I see 1 0 2 3 4, okay, for two, 12 we would have added 1, we would have added 45, we would have added, okay. Now again for this 45, if we see, I don't know, okay, that which difference I have to calculate or which one to consider. So when I come at 54 here, how will I know, okay, I have calculated difference from this or this? So for that case, we can store a list of indexes of any value. So here what we could have done is, instead of storing 2, we could have stored 3 as well. And so this is the index 2, this is index 3. And now when I come at 54, I see 45 is there in the map, which is reverse value. So with 2 I'll calculate the difference, then with 3 I'll calculate the difference. So this is the approach where I am storing the list of the indexes, because there can be multiple values, okay, there can be repetitive value in the array. So this is the approach, but if we observe carefully while going through the array, I mean we are going in this direction, and anyway when we come at 54, right, if we see 45, this 45 which is seen at first, then this 45 which is seen second time, so definitely if I am going to check the reverse for this value, so minimum difference needs the recent one, right? I don't want to know even like if there previously any exist or not, because minimum difference will exist with the recent one, not the previous ones. Let's say there might be more 50 45s here, 45 45, so then so if I go more further like this, difference would increase, right? Rather this would give me the minimum difference. So in that case, this list is actually not required. I mean, I told you in case of repetitive, there is a case which we need to think of. After thinking, we see, okay, we are iterating on the array in one direction, and going through, we see that this is not even needed, keeping the list, because if we just have the latest value, that will give me the minimum difference. Okay, so for that reason, if in this case we see 45 again, right? So instead of storing list, what we could have done is, instead of 2 we could have just stored 3, we could have wrote that value. So that is basically the optimal approach here, that instead of having this value stored, uh, list of indexes, I'll just keep overwriting. So this is my value. Okay, so already I did the dry run for this one. Now there is one more catch if you see. So what I am doing right now is, um, I'm at this index 0. I see if 21 exists or not, and I keep on adding into the map accordingly the value. But now let's say if we have so this works in this array, okay, but now there is one catch, that let's say this is our array, okay, where we have the value 120 and 21. Now let's say we have our map which has key, that is our value, and then index, that is our key. Now I came to 120, I see if 120 exists in map or not. I mean reverse of 120 is 21, right? Because we are terminating this leading 0. So I'll see if 21 exists in map or not. It doesn't exist. So what I'll do is, for 120, I will store index 0. Now I came at index 1. I see 21 exists in map or not. Sorry, for 21 the reverse is 21's reverse is 12. Okay. So I need to check in map if 12 exists or not. I see 12 doesn't exist. Right. So what will happen? I will end up saying that there is no mirror pair in this array, and we can return -1. Okay. I mean, as per our uh, current solution. But this is wrong. As we know that reverse of 21 is 12. sorry, reverse of 120 is 21. So this do exist in the map, but due to this leading zero, which here it has, we are not able to find that. For that reason, instead of storing the current value in the map, what we will do is we'll store the reverse value. Okay, so now what we will do, we'll have the same thing, and instead of storing it, we will store the reverse value in the map. So I came at 120. What is the reverse of 120? That is 0 to 1. Leading 0 will be cancelled. So 21 is at index 0. Now I came at index this 1 and I see 21. What is the reverse of 21? It's 12. So 12 exists in map or okay, sorry. For since we are storing the reverse value, we have to check for the current value itself. So at 120, we see if 120 exists in map or not. It doesn't exist. So we store the reverse in the array. Now if we see 21 exists in map or not, 21 does exist in the map. So for 21, I see it's here, the value is here, which means we have its reverse value in the map. So we'll take this index difference, that is 1, and I'll have our minimum answer as 1. Okay. And at the end, I'll also put this reverse of 21, that is 12, into the array. Okay. So that is why we need to store reverse of past elements. Okay. Normally, if we just store the current elements, it won't work that way. So we have to store reverse of past elements, and we have to do comparison on the current element if it exists on map or not. So this was the key thing. Okay. Now that is one part of the array. Sorry, one part of the question. Now the next part is having, I mean, this is the easy part basically. We have to calculate the reverse of this value. Okay, 120 is there. This is the integer value. I need to know reverse of it. So there is, I mean, two approach for this. Okay, so one is very simple one. Since it's an integer value, what I can do is I can take a string value from here. Okay, so we will do it string. Then what we will do, we will reverse it. We will get the reverse of that value, and then we can again turn this back to integer. So this to string will make it like this. Reverse will make it like this, and again the string value will make it 21. Okay, so after this we will have our array. But if you see, for doing all this operation, we might need additional string to store the value, and that will be additional space for this. Rather, we can go math, we can do the math here. So we have to compute this value 120 reverse, so we can have this reverse variable which will store the reverse of this value. Now while our value, let's say this is a value is greater than 0, what we will do is, what this reverse will do, basically it will have the this value into 10, that is reverse into 10 plus mod of this value. Okay, so value mod 10. So it, in this way, I'll get this value 0, and then every time what we will do is value equal to value divide by 10. Okay, and at the end we can return reverse value. So I can just do a quick dry run over here. So in first case, if you see here, what is reverse, it's currently 0, and it's currently 0. Reverse into 10 will be again 0. Okay, so it is 0 plus value into value mod 10. So if we do mod of this 120, it will be again 0. So my reverse is now currently 0. Okay, value divided by 10 will give me value equal to 12. Currently it was 120, now it's 12. Now again this value is greater than 0, right? So I have to do until it's greater than 0. Again, I'll calculate my reverse, that is 0 into 10, which is again 0. Okay, again in next iteration it is 0 plus value mod 10. So at this time it will give me 2. Okay, so now reverse value is 2 and value will be value divided by 10. So this time it will give me value is 1. Okay, so value is again greater than 0. Again I'll do another iteration. Here the reverse into 10, 2 into 10 is 20 plus value into 10. So this value in sorry volume mod 10. So mod 10 will give me value 1 and this value 1 divided by 10 is again 0. So value is greater than 0 and I can return my reverse value which is 21. So this way we can compute the reverse also. Okay. So this is approach for this problem and we can now look at the code and at the end we can discuss the time complexity as well. So let's code this out. In this solution, if you see, we have taken an unordered map of integer comma integer, and the minimum distance I have taken as int max. And while iterating in the loop, I have this reverse value, which gives me the reverse for the nums of I. I see if this value exists in map or not, the current value exists in map or not. Yeah, so I have added reverse value in the map. Now at the end, if you see this value, if our minimum distance is int max, which means there is no such mirror pair, in that case we will return -1. Otherwise, whatever min distance we have calculated, we will store that. So this is the coding solution for this problem. Let's run this. Okay, so all cases are passing. Now we can submit this. Okay, this is accepted. So now let's discuss the time complexity and space complexity. If you see, like, our solution is like we are iterating in the map and sorry, iterating in the array, and we are keep adding the value into the map, and alongside we are having the calculating the reverse. So now you see the constraint, nums of I can max, it can be 10 to the power 9. So in 10 to the power 9, if you see how many number of digits would be there. So here we can see number of digits would be log of this, let's say the value is x, which is base 10 plus 1. So this is the number of digits that will be there in the map. If we see in our case, so log of 10 to the power 9 base 10 plus 1, so this will be 9 plus 1, which is 10, and which is right. So this is the number of digits. So here we can have this value. This is the max value that we need, and max value in the array. So time complexity, if we say, so it is O of n definitely for iterating over the array, and another is log of x. So where this x is the maximum value in the array. Okay, so log of x will basically give me the number of digits, because the time complexity to reverse the any number is like number of digits is the time complexity for reversing any number. So number of digits is the time. So this is the time complexity. Space complexity, if we see, so we are just using an ordered map. So it will take another O of n space uh, for storing all the values in the map. So yeah, that's all for this. I hope you liked this video, and thank you for watching. Stay tuned for next video that I'll post tomorrow.